Hello, this is Miss Parks, and I know this is Algebra 2 because I'm using it from an old Algebra 2 class, but this is also for Integrated Math 3. We are going to, I'm going to put a lesson before we do section 3.5 so you can get a better idea of what the graphs are going to look like, why we're factoring functions in order to be able to graph them, and how to write the equations when they're not just quadratics. So quadratics are all parabolas. So we're going to go over a few things, and I would like you to write these things down as well. So we're going to do this more as notes. I know it says equations quiz. These are going to be notes for right now. So we're going to be writing down the X-intercepts, the Y-intercept, there will only be one, and then the degree of the polynomial, okay, or in the leading coefficient, I guess. So the X-intercepts will be the opposite of these, okay? So the X-intercepts are going to be -2, +2, and -3. And that comes from those. Okay, so I'm going to plot those points. And since the highest numbers are 3 and -3, I'm just going to go ahead and space this out. 1, 2, and 3, and 1, 2, and 3. So at -2, wherever you have a point, make sure you write a number. At -3, and at +2. All right, so those are the 3 points where the graph is going to hit. To find the y-intercept, you're going to set x equal to 0. So basically, y will equal whatever this is when x is 0. So 0 + 2, 0 - 2, 0 + 3, which is 2 times -2 times 3. And if you multiply those together, you get -12. Okay, so the y-intercept is -12. I know we can't reach down there, so I'm going to put -12 right there and put the y-intercept. The degree of this polynomial is that you have an x here, an x here, and x here, so it's x to the third, and the leading coefficient is positive, so that's a positive x to the third. Whenever you have a positive x to the third, that parabola, or that polynomial is going to go up, okay? So it's going to go up like this. It's always going to end pointing upward if it's positive, and because this is odd, that means that the other side has to point in the opposite direction. So for all the odd ones, positive, odd, they're going to go up like that. And then for positive, even, they're going to go up like this. They're going to both point in the same direction, okay? These are all smooth curves. So when you're drawing this, it's going to look something like this. Okay, so you want to think of like having a parabola. And 12 really should be down lower, so this would go like that. And you can kind of get an idea of what that's going to look like. You might want to sketch it out a little bit first. So between here and here, you want to think of it as if it was a parabola. Okay, so we don't know how high it goes unless we put extra points in there. And they should try to be smooth curves. So like a roller coaster, you don't want to go diagonally when you're doing this. So here we go. And then put arrows on each end, please. And these are necessary for each one, please. All right. And again, you're just learning this, so go ahead and just take notes on this for right now. For the next one, we have X-intercepts. Now, because of this 2, that means, and I'll explain what that means, that's a double root. We have 3, and for the second one, we have a -3. So these are my X-intercepts. Okay, so again, 1, 2, 3, 1, 2, 3. We don't have any numbers bigger than that here. So my points are at -1, at 3 and at -3. So what a double root does, it means that when the graph hits that point at a double root, that means that it's going to hit it, touch it, and turn around. So it's either going to go like that. Okay, so when it hits, it does not cross that line, or it's going to hit like this. One or the other. Okay, so for a double root, it's a oh, forgot I turned on that. For a double root, one of two things will happen. It'll touch that and turn upward, or it'll touch and turn downward. One or the other, depending on how this graph goes. So we need a little bit more information. So now we need the y-intercept. The y-intercept comes from making all of the x's 0. So f of x, or f of 0, let's just say y, equals negative 0 plus 1 squared, 0 minus 3, and 0 plus 3. So that's negative 1 squared times negative 3 times 3, which is 1, because we square first, and then we'll do the negative sign later. And then negative 3 times positive 3. So this is going to be positive 9. So that's the y-intercept. So I'm just going to put that at the top. So I know now the 4 points where it's going to hit. The next thing is the degree of the polynomial. Okay, so the degree is x squared times x times x. So that's an x to the 4th. And why can't I write this? It's negative because the leading coefficient is negative. So because it's negative, that means it's pointing downward at the end, and it's like a negative x squared. And we figure about how many at the most, basically. So if it's 1, 2, 3, 4, it can hit 4 times at the most. But in this case, you can see that it's only going to hit the x-axis 3 times. The reason it's only hitting the x-axis 3 times is because -1 is a double root, which means that it's almost like it hits it twice, once on the way up and once on the way down. So this graph will start by going up. It will not cross that. It'll go through the 9, and then it's going to come back down here. Okay, so when you draw this, the biggest mistakes that I get are people want to go like this, they draw it, they go to the 9, and then they go like that. And they want to make that diagonal. And I don't want you to do that. 9 is not necessarily the point at which it turns. If you want, you can kind of think of this as it can even go through the 9. It doesn't have to be the highest point. Okay, and then it'll come back down this way. So you're just getting started, so it doesn't go straight down. It's almost straight. And then I'm going to have to turn here, and then I'm going to go through that and try to make it smooth. That's terrible at the end. Of course, let me try this again. Oh, hold on. All right. As you can see, it takes practice. It's taken me a few times to do this, and I've already done this worksheet before. All right, so that's the graph. It does not cross that point because this one is a double root. Okay? All right, next one. And again, this is just an introduction to graphing so that you can see how it goes. You'll have your chance to practice. In this case, we start with X-intercepts. We have a 3, and this is a -1, and this is a triple root. And yes, I want you to write that down. This is a triple root, and I'll explain how those work when you draw them in a second. Then we have the y-intercept. So we make the x's 0, 0 minus 3, and 0 plus 1 to the third, which is negative 3 times 1 to the third, which is negative 3 times 1, which is negative 3. All right, 1, 2, 3. That's the y. That's the x. And then that's the other x-intercept. Now, for triple roots, let me show you how those work. For triple roots, one of two things is going to happen. And I'm just going to draw a dot. So we're going to, let me draw this. Let's see how I could do this. I'm going to try to draw this in a light gray. I'll just draw it in pink. So this is not a triple root, but just pretend that you had a parabola there and a parabola there. So what a triple root does is it's like you approach it as if you were going to turn downward, but then instead you go up. Okay, so this would be one example. And then the other one would be the other one. So if you're coming from the top, you would approach it as if you were going to turn up, and then you would turn downward. Okay, so triple root is like a cubic function. So part of it goes up and half of it goes down. Okay, but think of it as half of a parabola on each side, and it'll help you to draw it. So the x-intercept is negative, or excuse me, the y-intercept is negative 3. And then the degree and the power, this is 1x, and there's 3 here. So this is an x to the 4th, and it's positive. And since the last one was negative, it would point downward. So they both point upward. Now, it's not going to look like this. I'm just going to show that both ends go up. You can tell that it only hits twice because of this triple root. So that means that we're starting from up here. Okay, so let me show you before I actually draw it. This is going to be, so I would approach this as if I was going back up, but instead I'm going to go down, and then I'm going to come back up this way and go through there. Okay, so again, think of this as if having like two parabolas here. So when I draw it, I'm going this way. I have to hit that, and then I'm going to go up. All right. So we're actually going to be doing the one that looks like this one. Okay. All right. So here we go. So I start up. And remember, you have to start up and end up. So that goes like this. And again, instead of going back up this way, think of a parabola here, and I'm going to go down. I don't have to turn right at that point. Remember, I'm going to go through it and try to make a smooth curve that goes back up. Okay, so I do need to hit that point, that one, and that one. All right, so triple roots are like this. They're half of two skinny parabolas. All right. Next page. Let's go ahead and do these. Go ahead and try them and see how you do on these two. Okay, and then after you pause the video, you can come back. This first one's a little bit different because this right here for the x-intercepts, I guess I should. This is a 0 when you have an x squared, so 0 is a double root. And then we have 2, and then we have negative 3. Actually, maybe I'll help you with the x and the y-intercepts. Anytime you have 0 for an x-intercept, that means that has to be your y-intercept as well, because it already hits the y-axis and there's only one y-intercept. But you can do it the same way I showed you. So that would be 0 squared times 0 minus 2 times 0 plus 3, which is 0 times negative 2 times 3, which is 0. That's the y-intercept. We have x squared and an x, so there's 4 total. So we have a positive x to the 4th. And then if you haven't already tried to graph that, please do that, since I've kind of written out the most important information for you. So I'm going to plot all the points, and then I would like you to do the same and see if you could draw that out. All right, hopefully you've already finished. It's a positive x to the fourth, which means that it's pointing up, and because it's even, both ends are pointing up. For the 0, we cannot cross through the 0, okay? So that means that we're going to be going down this way. We're going to go up towards the 0. We can't cross it, and then we got to go back up towards the 2. So it should look something like that. All right, try the next one on your own, and then check it when you're finished. All right, X-Intercepts, -2, double root from here. That is not an X-Intercept because it has no X attached to it. All right, and then 1 for my X-Intercepts. My Y-Intercept is -2 times 0 plus 2 squared. You only put the 0 where the X's are, and 0 minus 1. Which is -2 times 2 squared times -1, which is -2 times 4 times -1, which is 8. That's the Y-intercept. So I'll make the top of this an 8. So -2 is a double root. 1 is a single root, so we'll go through that. The degree is that you have 2 x's here, 1 here, so it's an x to the third. And it's negative because the leading coefficient is -2, okay? So negative means it's going to be pointing downward at the end. And because it's an odd degree, that means it's going to be pointing upward at the beginning, okay? So that's what that means. So negative means it's pointing downward. If it was negative and even, they'd both be pointing downward. Because it's negative and odd, that means they point in opposite directions. Remember, odd degree, opposite directions. So that means that this is coming from up here. This is a double root, so we can't cross that, and then we have to go through there, okay? So it's going to look something like that. That doesn't look great. So I might have to maybe go like this, something like that. But you can kind of practice that. All right, so double root, we can't cross the double root. And this should be like a parabola looking, and then I don't like that either. And something like that. Okay, so for the next problems for the second half of this worksheet, instead of drawing the picture, they're going to give us a picture and we're going to write the equation. So we're going to write the equation of the function, so we know it's going to be f of x equals something, okay? So in order to do this, we look at the x-intercepts. So the x-intercepts are -1 and 2, and that would be a double root. So when we write that for this first one, and we need to leave room for the a values, so that would be x plus 1. And this one will be x minus 2. But because it doesn't cross, that's a double root, we have to put an exponent of 2 there. So the only thing we don't have is the a value. So right now we have f of x is equal to a times x plus 1 times x minus 2 squared. So we need to figure out a. In order to figure out a, you need a point that's not on the x-axis to do that. It doesn't have to be this point, but that's just the point that we happen to have. It can be any other point on the graph that we know the value of, okay? Since we know the value of the y-intercept, so for the y-intercept, we know that that point is 0, 8. So we're going to be using that as our xy in this equation to solve for a. And then once we solve for a, we'll put that back in there. So f of x and y are interchangeable. So that means that I'm going to put a y here. For y, I'm going to put an 8. Then a. Then every one of the x's is going to be 0. in this case, remember, we could use a different point. So if it was a different point, we'd be using a different value there. So that's 0 plus 1 and 0 minus 2 squared. So now the only variable we have is a, which means we can solve for it. So we have a times 1 times negative 2 squared. So 8 equals a times, we'll just leave the 1 out. So 1 times a times, well, I'll put it there for now, times 4. So that's 4a. So a is equal to 2 if you divide both sides by 4. And since a is equal to 2, we put that back in, and then we have our answer for our equation. Okay, and that represents that graph. All right, so really that's all you have to do. You look at the x-intercepts. Each of those get their own parenthesis. You have to double check to see if there's any double roots or triple roots. And then you use the y-intercept or any other point that's given to you on the graph to solve for a. Once you solve for a, you plug that back in. All right, let's try the next ones. Let's go ahead and I would like you to try all of the ones on this next page and see how you do. I don't want you to use decimals, so if you do get an answer that's a fraction, please leave it as a fraction. Just reduce it. Actually, if you guys can just go ahead and do 7 and 8. It's something a little bit different on number 9, but go ahead and try 7 and 8. All right, hopefully you've done them all, at least 7 and 8, and then I'm going to go ahead and do that. So we have x plus 2 squared, that's a double root. For the second one, we just have x minus 2. Remember, we're using the opposite of these. And then for the last one, this is also a single root, so x minus 4. All right, so then the point that we'll be using is up here, and that point is 0, 5. That's my x, and that's my y. So 5 is equal to a times 0 plus 2 squared, 0 minus 2, and 0 minus 4. So this is going to be 2 squared, which is 4, times negative 2 times negative 4. So that's a times 32. And then if you divide both sides by 32, then that's what a is equal to, 5 over 32. So f of x is equal to 5 over 32 times x plus 2 squared times x minus 2 times x minus 4. And that's the equation of, or the function of that polynomial. For the next one, I'll leave the a part. So this is x plus 3. This is a triple root here. So this is going to be x minus 2 to the third. And the reason I know it's a triple root is because it comes down at one angle, and then it turns to the other. So when you have that, that's a triple root. Okay? So we have y is equal to a times x plus 3 times x minus 2 to the third. We will use this point up here. So this is x and that's y. So 6 equals a times 0 plus 3, 0 minus 2 to the third. So this is 3. This is negative 2 to the third, which is negative 8. So 6 is equal to negative 24a. And if you divide both sides by negative 24, this reduces to negative 1/4, which is your a value. And then, yes, you need to reduce that. All right. For the next problem, the reason that we are going to have a problem here is you're going to have f of x is equal to something times, and then 0 is a double root. So it's like x minus 0 squared. So we just put x squared. And then 2 is a double root. So then we have x minus 2 squared. The reason we cannot find the a values because we don't have a point that's not on the x-axis. And you can't pick a point that's on the x-axis because you're just going to get 0 equals 0. So because we don't have any other point, we can't use the y-intercept because that's 0, 0, and basically would just make everything into a 0. So in this case, we're just going to go ahead and put a 1 in for the a value. If this happens, the a value can be pretty much anything. We just have to figure that out. I would have to give you some more information in order for you to figure that out. For now, we're just going to leave that as a 1. All right, one last problem. Go ahead and try number 10, please. And we're going to be done with this section, which is, again, kind of an introduction to graphing these. We haven't really graphed these ourselves, and writing equations. All right. Hopefully you finished number 10 already, and then I'm going to finish that now. So the first one is a 5, so that's x plus 5. Second one is a 3, that's x plus 3. The third one is a 1, that's x plus 1. And then the last one, X-intercept, is x minus 3, and that will be squared because that is a double root. Okay, the Y-intercept is 0, negative 3. So y is equal to a. I know you guys can probably take some shortcuts here. I want to show all of the work. So we'll use this as our xy point. So y is negative 3. Then we're going to use 0 plus 5, 0 plus 3, 0 plus 1, and 0 minus 3 squared. So that's going to be 5 times 3 times 1 times negative 3 squared makes that a positive 9. So that's negative 3. You can actually cancel that 3 and that 3 if you wanted to. Equals 135a if you multiply all these numbers together. And if you divide both sides by 135, you should be able to reduce since they do have a 3 on each side. So if you wanted to cancel that 3 and that 3, you would see that if I got rid of this 3, that would leave you with 9 times 5 on this side. So this is negative 1 over 45 if you reduce that. And that is your final answer for number 10. That covers all of that. So then when we go into section 3.5, that's from the book, you'll have a much better understanding of what all the numbers mean.